Welcome to this presentation of the Hydro-Sequential Size Separator. I am David Petzer, the inventor and patent holder of this technology. Starting off with the unit empty, the main and control valves are opened and the process solution proceeds up these two pipes and into the receptacle vessel for the process solution. This is coded in green, the internals of which dissipate all the energy and ensure an even distribution right the way across the unit. The solution then overflows and proceeds to the base and then all the way across the segregation section as well as the separation section and into the overflow launder, which leads down to the thickener. The slurry is now introduced into a similar arrangement, marked here in grey. The energy is dissipated and the full width overflow joins the process solution overflow. The diluted slurry now proceeds down to the base of the unit, where it overflows a distribution weir and then down the open channel launder, where laminar flow undisturbed conditions are maintained. The objective here is to achieve partial segregation, allowing for some of the coarser material to migrate into the lower region of the slurry. The diluted slurry now passes into the separation chamber section, where it flows all the way across and into the launder leading down to the thickener. In this section over here, undisturbed laminar flow conditions still prevail, but now hindered settling starts to take effect. Here it is critical at all times that the horizontal velocity across the section is maintained above the minimum critical velocity to prevent settling of the -75 micron material. The first fraction to be removed is the grit. This is done with a variable speed screw extractor, allowing for a wide variance in feed. This drops down into a deep launder below. The second product to be removed is the upper grinds, and this is removed by way of a calibrated gate valve at the base, and this then joins the launder. The third product to be removed is the lower grinds, and it too is removed by a calibrated gate valve and falls into the launder as well. The products so removed report to a deep U-shaped launder situated below them. In normal operating conditions, the spade is raised at the end of the launder leading down to the milling section, and the last separation unit, there the spade is lowered. There is a gentle slope leading towards the milling section, and with the aid of strategically placed flushing water, the entire product is transported down to the mill discharge sump for further processing. During commissioning or periods when the mill is offline, the unit can continue to function normally, and the spade at the end of the launder leading down to the mill is lowered, and the spade at the other end of the launder leading to the overflow launder and the thickener is raised into the vertical position. With the aid of copious amounts of flushing water, this product is then moved backwards into the overflow launder and rejoins and goes down to the thickener. Should a situation arise where a reduced mass is required down towards the milling section, then with the final spade raised, the second separation chamber spade is lowered, reducing the flow towards the mill. The third separation chamber, this product is now flushed backwards towards the thickener via the launder at the base of that overflow. Recapping, the diluted slurry passes over the stabilizing weir down the open channel flow, achieving partial segregation and into the separation chambers. The first product, the grit, settles out, and here it's designated in orange, possibly 105 microns and larger. The second product is the red, and is classified as the upper grinds, possibly minus 105 plus 88 micron. And the third separation chamber, designated here in blue as the lower grinds, minus 88 plus 75 micron. The purple is the fines, the minus 75 micron, which is kept in suspension by virtue of the horizontal velocity across the unit. In order that the unit be taken offline without interfering with the main incoming slurry line, a trapdoor is installed above the stabilizing weir. When activated, this trapdoor diverts the total diluted slurry out through the side of the unit and all the way down to the base of the overflow launder, and then proceeds to the thickener. In the Mark II version of this unit, the separator is installed adjacent and below the linear screen, and the diversion takes place in the linear screen underflow launder, thus obviating the need for the trapdoor and the bypass launder on the Mark I version. This reduces the overall height and reduces the capital cost. In summary then, a cost-effective way of recovering the plus 75 micron material for subsequent treatment and improvement in gold recovery. A robust unit with essentially one moving part and flexibility in terms of the incoming slurry, as well as the ability to accommodate variances in the milling section. A pilot plant is to be constructed early 2023, where a bulk sample of material will be tested to determine the optimum operating conditions of the unit. This will then be repeated sufficient times to generate a sample large enough for the production of a gold versus recovery graph. Investigations could also include the uraninite and thucalite effect to determine if a improved gold recovery can be achieved by their dissolution. Thank you very much for watching.